Hello, pre-calculus students. Today we're starting our next day of conic sections by way of video, and today's topic is the ellipse. The ellipse kind of looks like a scrushed down circle. The ellipse, again, the focus, right, or in this case the foci, because there are now two of them, they really tell the story. They give us a really good property of an ellipse. In a lot of places in the U.S., they use an ellipse to break up kidney stones, believe it or not. They place the patient over here, and they try to get the kidney stone as close as possible to that focus. And then this is in a big tank of water, okay, where the sides are made of steel. And at this other focus is a sound source, high-frequency sound source. And what happens is, the property of an ellipse is that you can tell when sound waves hit the ellipse, if the sound wave originated from the focus, it's going to go right to the other focus. So, again, doesn't matter where the sound wave hits, everything is going to get bounced right to that focus. And by concentrating all of that, it's able to break up kidney stones. They use this in many hospitals. An ellipse is also the source of the first spy device actually in the U.S. At the U.S. Capitol, the top, the dome of the U.S. Capitol is an elliptical shape. And what happens is, if two people are standing at the two foci, and they could be like about 100 feet apart, the sound waves as this person talks hits the roof and goes right to the other person. So what a lot of times they would do is have the foreign dignitaries stand way over here, and the U.S. delegates would walk way far away so they couldn't hear them. As long as the U.S. delegates were quiet, they could hear what anyone was saying if they were at the other focus. There's lots of other applications of the ellipse, but the thing to remember again is that when you're at one focus, it bounces off the ellipse and comes right to the other focus. The other property of it is this, is that these two sides, A and B, right, they always add up to some number, like 10, 11, 12, whatever. It's always going to be the same number. It doesn't matter what the two segments are, but when you add them together, it's always going to add up to be the same number. Friday, I'll try to show you an example of that when I'm in class. But for now, I need you all to copy down this picture and this equation. Okay, you're going to need this for today's assignment, and this picture pretty much tells you everything you need to know. So we know the ellipse has a center, right? And then it's got a vertex. It's got two of them, vertices. That's on the longer axis of the ellipse. We can tell on the bottom right where I drew another ellipse. Here the vertices are the two spaces on the top, but notice it's along the longer axis, okay? Minor axis, I think we can tell, is the shorter of the two. Let's see, if these are the vertices, well then the other 2 points will be called the co-vertices. Again, major axis is the longer direction, right? The major axis is this entire length, whereas the minor axis is the smaller one. And then also, to find the focus is always on the inside. It is going to be a distance of C from the center, okay? Now to calculate the C, it's just going to be a squared minus b squared, okay? Where a squared and b squared are the parts in the bottom part of the fraction. We're going to go ahead and go through two problems that kind of make you find all the pieces you need that'll help you with the assignment. So go ahead and pause the video now if you need to finish drawing this picture so you have it, because you definitely need it along with the equation, along with this stuff on the bottom left. Okay, so pause it now if you need to copy it down. You don't have it down yet. Okay, well, here's what we have to do. On the assignment, you'll be given an equation, and we're going to need to get it into standard form and then find all these pieces and then also graph it. Well, the way I know it's an ellipse is that just like a circle, it has an x squared and y squared. But whereas a circle, both numbers were like 4x squared and 4y squared. In this case, they're not the same number. This is 1 and the other numbers are 4. As long as they're different numbers, it's going to be an ellipse. Now, they both have to be positive or negative. And if they're different signs, we'll talk about that later. But right now, they have to be different numbers and the same sign. Well, to get it in the right format, we do just like we did before. Put the x's in one parenthesis and the y's in another parenthesis. And then again, move the positive 9 to the other side. Now we're going to go ahead and complete the square. Factor a 4 out. Let's see, we've got to add 9 to here to balance out this 9. And then we've got to add 4 to balance out that 1 because it's really 4 times 1. Okay, write this out factored. And then to get it equal to 1, because if we go back, excuse me while I go back, notice equation is going to be equal to 1. That means we need to divide everything by that 4. So we're left with x plus 3 quantity squared over 2 squared okay. These 4's cancel. I'm going to put a 1 down there. That way it matches up with the form of the equation we have. Again, these things in the denominator have to be to the second power. So since this one on the left was a 4, wrote that out as 2 to the second power. Well, the center will be at, let's see, the x value should be a -3 and the y value should be a 1. So there's that. Now to figure out the vertices and co-vertices, what I do is this. I look beneath the x value, and beneath the x value is a 2. So I'm going to count a distance of 2 to the right and 2 to the left because I'm going in an x direction. Beneath the y is a 1, so I'm going to count down 1 and up 1. And lo and behold, that gives us our ellipse. Now the vertices should be these 2 blue dots, right? Because they're the ones that are farther apart than the others. And so let's see, we've got that at -1, 1. And let's see, 1, 2, 3, and -5, 1. Co-vertices are the 2 red dots. That's at -3, 0 and -3, 2. The length of the major axis is the longer one. That has a length of 4. And then the minor axis is the one going vertically. That has a length of 2. And then to figure out the foci, again, c squared equals a squared minus b squared. So that means that c squared has to equal. Now, I don't get hung up on what's a squared and which is b squared, but I know when I subtract them, it better be positive, right? Because we have c squared going on here. So I think the order has to be this. Because if the order was backwards, 1 squared minus 2 squared, we have a negative number, and that's not going to work. So we now have c squared equals 4 minus 1. So c is equal to the square root of 3. And it's always going to be pretty much an ugly number for this. Now, again, remember, to find the focus, we move over a distance of c from the center. Well, here's our center, right? So it's going to be at -3 plus the square root of 3, comma 1, and -3 minus the square root of 3, comma 1. Because we're going to be adding and subtracting the square root of 3. And since we're at -3, that's what we're going to do. We want this exact value, okay? It's not too bad. Pause. We're going to do one more of these, but pause the video if you need to, so you can look at it a little bit more. All right, here's our other problem. Now again, we're going to do the same thing we did on the other. We're going to complete the square first. So I put the x squareds in one parenthesis, and I put the y squareds, or the y values rather, in the other. And again, the 80 we put to the other side. So I'm going to factor the 9 out of the first parenthesis and the 16 out of the other. Okay, I think we can complete the square here. Half of -4 is -2. -2 squared is 4. But we really have 16 times 4, which is 64, right? I'll make this a little bit better. Which means we really have 9 times, x minus 0 squared. And this would be y minus 2 quantity squared. Equals 144. Well, on all these conics, again, we've got to get it equal to 1, so we're going to divide by 144 here. And that leaves us with, I'm going to write it off on the left-hand side here, now that we got it in the right format, we can figure a bunch of stuff out, like the center. The center's at 0, 2. Oh, I guess instead of 16, I probably should have written that out as 4 to the second power, because we do want to make that format right. And the 9 should be 3 to the second power. Okay, well, beneath the x is a 4. So I'm going to count 2, 3, a 4 in either direction. Again, that's in the direction of the x-axis. Underneath the y is a 3. So I'm going to count 3 in the direction of the y-axis. Connect these up. Okay, I think we can tell that the vertices are going to be these two on either side because that's the longer piece. So the vertices are at 4, 2 and -4, 2. The co-vertices are the other two pieces. That's at 0, 5 and 0, -1. Now again, to get the foci, we remember that it's c squared equals a squared minus b squared. So c squared is equal to 16 minus 9, which means c is equal to the square root of 7, which is about 2.6. But as for the exact location, it's going to be 0 plus the square root of 7, 2, and 0 minus the square root of 7, 2. Now the length of the major axis, again, that's the long one, right? Which I believe has a length of 8. And then the minor axis is the other one, and it has a length of 6. Now, on the delta math, you're going to have to do this kind of stuff, figure out different pieces. Don't be afraid to sketch the graph. It's going to help you find a lot of information. And again, if you want to see me Thursday, come by, see me Thursday morning to get a pass for seminar.